Any sufficiently advanced technology is indistinguishable from magic.
Welcome, everybody, for what promises to be, fascinating conversation with one of my favorite thinkers and one of your favorite thinkers. Whenever I ask, who should I get on the podcast again, it's always Sabine Hossenfelder in the top one or two most requested guests. And she is our guest today, Dr. Sabine Hossenfelder, proprietor of the Science Without the Gobbledygook empire all around the world, joining us today from Germany. How are you today, my friend?
Good to see you, Brian.
It's good to see you, too. This is twice in a week. We're recording this at the end of July. We were together for the Institute for Art and Ideas live stream, which you can find. I'll put a link to in the show notes below. And that was a lot of fun, talking about consciousness, quantum mechanics, the observer, all sorts of fun things. But that's only a small fraction of both today's conversation and the wonderful new book that brings Sabine back, and that is called Existential Physics. And it is a phenomenal book that I read in hard copy. I read it in Kindle form, and your publisher was kind enough to send me the audio version, which is read by a wonderful narrator, Gina, I think her name is. Anyway, she's wonderful, the English version at least. I hope you do the German version. Sabina, what I love to do recently, since you've been on the show 4 times, but I've only recently started to make this a patented trademark segment of the show. I always begin by asking the authors who come on the show the meaning, the interpretation of the title of the book, of the cover design of the book, and especially of the subtitle of the book as well. So I'm wondering, can you do what we're never supposed to do and judge this book by its cover?
Well, so I have to admit that the title wasn't my doing. My suggestion for the title was More Than This, like the song. And it was supposed to say physics is so much more than what we learn in school, you know, balls rolling down inclined planes and resistors and all that kind of stuff. And this title, Existential Physics, is what my editor came up with. He wanted to get the word physics in the title. And I thought he has a point, that people know what it is about. So I gave ground on this, but I insisted on my idea for the illustration, which was a butterfly fading away into some kind of particles. So I wanted to say everything is made of particles. Like, this is what people always accuse physicists of, right? You want to reduce everything to the particles, and that's bad, bad, bad. And so I was trying to say, it's right, everything is made of particles, but that's not the end of the story. There's so much more to it, because there's all this complexity and chaos also coming out of it. And this is why the butterfly, it's supposed to allude to the butterfly effect.
And of course, your first book was called Lost in Math. And I kind of was thinking about this book, and maybe another title, if you publish with me someday, would be Found in Physics. Because I think, your first book kind of decried the situation of how, physics is being almost overarchingly taken over by this love of beauty and symmetry and organization, and thanks to math. And then this is kind of, things are blowing apart. The butterfly separating the chaotic nature, which is closer to reality, of course. And so, yes, and the subtitle is A Scientist's Guide to Life's Biggest Questions. And the commonality between these two books, your two books, is that you're kind of a heroine in your own story. One of my episodes with you is called The Heroine's Journey, because you go around the world in all your books kind of like a journalist. And I thought we would start there, if you don't mind, talking about how you come to interview these phenomenal scientists and authors, Zia Morali, Sir Roger Penrose, to David Deutsch, etc. But the first question you asked them, Sabina, was very surprising to me. You always ask them if God plays a role in their life. Why did you ask that question?
I've asked this question a lot of physicists, and I find it interesting that most of them answer. So what I ask them is, are you religious? That's the way that I put it. And they'll always say, no, but. And then after the but, there's the interesting part. And this is what I wanted to get to. The only person who didn't do this was David Deutsch, who was just like, no.
And Zia Morelli, of course, she embraces God. She's not a scientist anymore. She did train at my alma mater, Brown University, for some time, and I do hope to have her on the podcast as well. But she's a devout Muslim, and she does practice, as you say. You're coming off the interview with her, coming off of Ramadan. So I thought that was interesting. But actually, throughout the book has many topics, and it's interesting how much physics has come full circle. In other words, it used to be people like Galileo and certainly Newton and maybe even Einstein, although we can get into that, had this kind of overarching impact of religion on their life. Sabine, a lot of the conversations that revolve around God, unfortunately, a lot of what people end up saying is basically some kind of, in my opinion, warmed over version of either I don't believe in it or I'm agnostic. Which I used to leave open as a question if my audience, if my guest would say that. For example, my first guest, Freeman Dyson, on the podcast way back 4 or 5 years ago, he said, I'm agnostic, but it's a great mystery and I love doing it. And I said, that's great, Freeman, but what do you do practically? How do you distinguish your daily life from that of an atheist? In other words, if a super intelligent alien looked at you, he would say, you don't go to the same church that Richard Dawkins doesn't go to. And so I'm wondering, how do you react when people, do you ever have this notion that they're not being either intellectually honest or that they really just don't want to come out and say I'm an atheist, or they don't want to come out and say, as Stephen Hawking said, that would cut book sales, in half more than adding equations. Do you ever get the sense that they're kind of modulating their belief or lack thereof in a God or in a religion to either sell books or for some other purpose?
Well, I would put myself into the same camp. Like, I would say that for what my research is concerned, I would say I'm agnostic. This is also what I write in the book. Like, I don't take sides. I don't know one way or the other. But if you're asking about the way that I lead my personal life, I'm not religious. I don't go to church. So for practical purposes, you can call me an atheist. Right? So this is the way that people think about atheists. Right. So I don't know how other people do it. I often get the sense that scientists, physicists, which is the kind of scientists that I mostly deal with, they kind of replace this religious element that they've taken out of their life by some other kind of belief. There could be a multiverse, or it could be the beauty of natural laws, or whatever have you.
Yeah, I get that a lot too. In fact, I did a video for this, they're mostly a conservative talking, network called Prager University. And I did What's a Bigger Leap of Faith, God or the Multiverse? And I did it because, it's hard to reach, a predominantly Christian audience, that is conservative and teach them about science. And I wanted to do that. And two of the people I quote from are you and Paul Davies. But they actually distilled one of your online essays at Back Reaction, your phenomenal blog, where I've been roasted at least once. I've been hosted multiple times, but I've been roasted once for my first book. We're not going to get into that. But we took an essay, or they took an essay, and they distilled, like from Dr. Sabine Hossenfelder, here's all these commonalities between religion and the belief in the multiverse. And you're not saying they are a belief in a God, but there are certain similarities. And yes, you bring this up when you talk about things like the simulation hypothesis, et cetera. And what do you make of the fact that so many scientists were religious, even 100 years ago, but now very few? I mean, in the U.S., 93% of the National Academy of Science does not believe or actively does not profess a belief in God, at least here. I don't know what it is like in Germany or Europe. But what do you make of this huge, that's a huge phase transition from almost 100% universal belief to 7% at best. What do you attribute that to?
Well, to be honest, I think it's a mistake that the traditional churches, like the big churches, make. Like, basically here, almost all people are either Protestants or they're Catholic, and they hold on very closely to these very traditional stories, which, if you think about them too much. They don't really make a lot of sense. And I think this is what put me off from church. So I actually went to church for quite some time, when I was a teenager, because I was interested in it, and I liked the singing. There was free food, and that kind of stuff. And to be honest, I like the social get-together, which at the end of my book, I say that science leaves me wanting in that regard. We could do better when it comes to the social aspect. But I think it's kind of unnecessary. Like there's key elements to this belief, which I think people find attractive, and it expresses something that they care about, which doesn't hinge on the literal interpretation of certain phrases in the Bible, that kind of stuff. And so I think that what puts scientists off those religions is that there are just certain elements that they can't get themselves to subscribe to.
Yeah, right. They want to believe that everything they do is rational, but I don't think a person who did everything rationally would appear very rational. In other words, I think we all have irrational beliefs, and then some are more irrational maybe than others. And it's kind of it almost provides an outlet for people. Like, we're going to combine things. I was interviewed recently, and someone asked me, like, what do you want to discover with the Simons Observatory? Or what do you believe? Did inflation occur, or was there a bounce? And we're going to get into those subjects in just a bit with you, because they feature prominently in existential physics. But I said, I don't want to believe in anything. Like, I want to have evidence for something. Like I said, I always joke, I don't believe in gravity. I don't have faith in gravity. We have evidence for gravity. And one of the consistent themes in your wonderful new book is the power of a scientific idea is that from which you can make calculations and you can make observations comport within the context of that particular framework. But I'm wondering, to push back with respect, as I always do, there are situations where people explain data using models that are completely wrong. I'll point out Kepler, right? Kepler used Tycho's data and other observations, and he made it beautifully fit into this model of the solar system that had. I gotta put these in here, Sabine, because I bought these just for our interview. So he had these crystalline, spheres, and he had orbs, and he had pyramids and all sorts of cool things, and he got the right answers. So how do you react to that? How do you react to the fact that sometimes a totally wrong idea can still be consistent with data? Are we in danger of being too beholden to the notion that everything has to be falsifiable and et cetera, and Popperian? Are we too in love with these ideas lately in terms of our scientific research?
Well, you say it's a totally wrong idea, but the only reason we know this is that we got better data and it didn't fit to it, right? I mean, and this is exactly how science is supposed to work. So this is all well and fine. I'm not sure I see the problem there, but I mean, as you say, it's what I'm.
I think it's
what I'm trying in my book is I'm trying to distinguish between what we actually know, what we can read out of the data, and where we supplement what we actually know with belief, which isn't wrong, but I think as scientists we shouldn't mix the two things together.
Mm-hmm. So you would say then that the lack of evidence for a multiverse or for a simulation hypothesis or many of the myriad things that we can get into, that is provisional. In other words, it could be the case that that inflation took place or a big bounce took place or there's a multiverse, but we have to wait because we don't have enough data? Or are there certain things you can say are never going to be true no matter how much evidence we collect?
I wouldn't say this, but when it comes to stuff like the multiverse, I can't even think of any evidence that could possibly support the hypothesis. So this is the big problem that I have with it. On a slightly more technical level, the issue I have with many of these ideas is that they make assumptions which are actually unnecessary to describe anything we observe. Like this is the big issue with the multiverse. You can say, well, there are all those infinitely many universes out there, but there's no way we can observe them. Not just that we can't see them. There's no possible measurement that we can ever do to find evidence for their existence. Then I would just say, well, it's not a scientific idea. Right. And so you're free to believe in it if you want to. It's fine if you want to believe there are infinitely many other universes and there are copies of you in many of them and they do whatever they want. That's fine, but please don't pretend it's science.
So you also say in the book you make commentary on some past guests, some upcoming guests, but it seems that one of the biggest targets for your ire or at least your bemusement or befuddlement is Max Tegmark and those people of his kind that like to promulgate the idea of what he calls the mathematical universe, which is not only one multiverse, as I understand it, is at least 4 different kinds of multiverses, some of which I don't think are controversial. In other words, that he says there are things we cannot see that are outside of our horizon. I don't think you would disagree with that. You might say that that's not a multiverse, but at any rate, why do you say, as you do in the book, that this kind of thing was probably done to sell books, and for that it was quite successful? Why does that particular conjecture annoy you, as you say?
I don't think I say this in the book. I think I have one sentence in which I mention Max, which is something to the extent, I think he only came up with the idea of the mathematical universe to prove that he's a seriously weird fellow, which I think is appropriate given that he calls himself Mad Max, right? And so, don't get me wrong. I really love him. He's cool. And it's a very thought-stimulating idea. And I think generally this is why people like the multiverse, because they like thinking about it. And there's nothing wrong with it. But it's a philosophical idea that all this mathematics actually exists in some sense. It's not a scientific idea. I don't think he came up with this because he wanted to write a book and sell the book. Doesn't really make a lot of sense, does it?
Well, yeah. I mean, I think, I agree. He has more integrity than that kind of characterization. But I would say, one thing that people push back on where I have these debates is, well, didn't so and so demonstrate that you could see the impact of a bubble collision in our universe, and isn't the CMB cold spot, or couldn't there be other anomalies? Our friend Arvin Ash is doing a video this week on his wonderful channel called Dark Flow, and it's about possibly there's another universe pulling our universe towards it, and so. There are people that say, no, Sabine, you're wrong. We can falsify the multiverse. It might take a couple of trillion years, but it's in principle falsifiable. What do you say to people that come up with ways to prove or disprove the multiverse using evidence?
For one thing, as you've probably seen, I address all those points in the book, and I have also a video coming up, which I already recorded, in which I say, these are the typical points that physicists always bring up to me. Like the first point is usually you skipped over this, Brian, which is black holes. We can't see inside a black hole. Then, the second one, but there are also, no one expects the universe to end beyond the cosmic horizon. Then the third one is what you just said, where you can actually see it. And there's a fourth one. It's simple. That's the fourth one. So we can get to this if you want to. But so the thing with the idea that you can actually observe it, I think this is what's called a bait and switch tactic, right? First we're talking about this general idea of the multiverse with these infinitely many copies of you and blah, 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 blah. And then suddenly you're talking about a very specific proposal of a multiverse, which maybe, the one with the entanglement. I think this is the one with the dark flow, right? And then there's the idea with the bubble collisions and so on. And look, those actually make predictions. And that's a slightly different problem, which is that physicists think that just because something is falsifiable, it's also good science, which I say, well, you've misunderstood pretty much everything about the basic philosophy of science. But also, I mean, if you just look at how it went with those predictions, well, no one's found any of this evidence. Like, they've actually looked for it, like these particular patterns. I think Will Kinney wrote a paper about this idea with the dark flow, and then the thing with the bubble collisions. I mean, you know that they haven't actually found the signature, right?
Right. And I think, yes, you're absolutely right. I mean, people say, oh, falsifiability means it is science, but I can prove to you that my astrologer, yes, I go to see an astrologer, you know, she made a prediction. It didn't come true. Therefore, it must be science, right? So, but one person you do call out by name is upcoming guest Nick Ballstrom, who you say the simulation hypothesis, and I'm quoting, annoys me. Why does it annoy you? How can a scientific idea or philosophical idea annoy you?
Well, if they would just use it as a philosophical idea, that'd be fine with me. But it has this, they're trying to give it this scientific flavor, right? And what it actually is, the simulation hypothesis, it's a statement about the properties of the fundamental laws of nature. And that's something which physicists deal with. It's not philosophy. And so if you believe that you can actually encode general relativity and the standard model of particle physics on a particular type of computer, then you better tell me how you're going to do this. And it's not a trivial problem. I mentioned some examples, like especially when you're talking about chaotic systems and that kind of stuff. It's not as simple as just saying, well, you know, if no one's looking into this corner of the world, I don't have to compute it. That's cheating, right? Please show me your algorithm, and then show that it actually reproduces our observations. And of course, they don't do this. Like, they don't even get anywhere close. And this is why I say it annoys me. Now, if you want to talk about it on this philosophical level, like we may all be simulations or brains in a vat or whatever. I'm like, yeah, do what you want.
Yeah, these are old questions, and I feel like we recapitulate all these things every 10, 20 years. It's said we have to rewrite the literature of what came before because it's expanding at an exponential rate, and therefore, I think it just behooves people to want to make a contribution to it. And from there, I want to turn to another topic that I get a lot of questions about, and a lot of my fans listening and watching you will want to know something you don't really talk that much about. You probably have a video about it. We'll get to your video oeuvre and your catalog in a bit. But and that's aliens, which are in the news almost every day now, ranging from people like past guest Tom DeLonge, claiming he has recovered portions of an alien spaceship when he came on my podcast, which was quite interesting to go down the rabbit hole with him and find out actually he can't verify exactly that he's owned it. Anyway, but I give him credit. He brought a lot of this, he was a musician for this band Blink 182. He lives in San Diego, great guy, fun guy. But, he kind of got this into the attention of the media about 5-6 years ago, and now it's risen all the way up to my friend and colleague and president of the Simons Foundation, Professor David Spergel. And David is now co-leading this NASA panel commissioned by the chief administrator on down to investigate the role of what they call UAPs, the unidentified aerial phenomena, but that could include UFOs, objects. It could include evidence and data. Of course, I've had on Avi Loeb and other people as well. But I haven't asked you about this. Where do you come down? Do you believe that there are credible bits of evidence suggesting that Earth? Well, first of all, that aliens exist, other life forms exist. Let's start there. Do you think life exists outside of the Earth? And is that a scientific question or is it a faith-based question?
Well, we don't actually have any evidence that life exists elsewhere. So at this point, I would say it's a faith-based question. So if you want to know what I believe the answer is yes. That's mostly because I think that it isn't as difficult to create complexity as physicists like to think. I think physicists have somewhat of a bias that everything is kind of simple, and then they think life is really, really difficult. So it has to be rare in some sense. I think that's not correct, but of course I don't know. Now, if you're asking about any particular type of evidence, right, I have to admit I haven't followed this at all. Personally, I haven't encountered any particularly, convincing evidence, but yeah, I haven't really looked into it.
Now, are you in the camp, or perhaps not in the camp, of those like our mutual friend Eric Weinstein, who suggest things such as the fact that we should devote some substantial resources to the investigation of the phenomenon because it might reveal new physics that could then be used to solve many predicaments that we have on Earth, namely, how do we get off the Earth without, as he says, putting chemical oxidants inside of a phallic-shaped tube and shooting it to Mars, as our friend Elon wants to do. But would you say that if we did find evidence of not just alien life like slime mold on Proxima Centauri B, but if we found technological, intelligent life, that would open up a new portal into physics that we would otherwise be ignorant to? Do you think that's even a conceivable prospect for humanity?
Well, it's certainly conceivable in the sense that I can imagine it. If the question is how likely is it, I have no idea. I mean, I agree that this is something which we should investigate. Now, if I think what you said was we should invest significant resources. Of course, that brings up the question, like, how significant, right? What amounts are we talking about? And I'm not really in the position to make that kind of judgment. As I said, I haven't really followed it. I would generally agree. Yeah, I mean, it's a really important thing. It's one of those things where the payoff could be so huge that it would be stupid not to look at it, right?
Mm-hmm. Yeah, I think that's absolutely true as well. And yet, the question of the level of fervor about it is kind of unmatched by the evidence. And I want to run an argument by you that I've used on other scientists that are more involved with this phenomena and even the concept of it, and that's this concept called panspermia, which was originally, it sounds dirty, but it's not. Don't worry, we won't get our YouTube demonetized. But the concept was that life on Earth, it doesn't solve the origin of life problem, but it solves the origin of life on Earth problem. And that's by these little objects called meteorites. By the way, you can get your own meteorite if you subscribe to my mailing list, briankeating.com/list. And if you subscribe to Sabine's mailing list, maybe she'll send you like a theory, or she'll tell you that you're full of gobbledygook. But you should subscribe to that. Sabine Hossenfelder has a wonderful mailing list. We'll put links to that below. But the theory of panspermia posits that life on Earth originated because objects like these meteorites had chemical life, molecules or precursors to life, or even life itself, and they can survive and they can land on the Earth, and then that causes Darwinian evolution to sprout, right? So that's the theory. But I invert that argument, and I say, if that's true, then we should see life on Europa or on Titan or on some other moon or asteroid or something, because we've had life on Earth for 4 billion years. It only took a couple 100 million years for life to get kicked off, and often Earth gets hit by meteoroids, and those blast off these same chunks of Earth, including life, and they should be floating around the solar system for literally billions of years. And some of them do land on Mars. We know that they've landed on Mars because we have stuff from Mars that landed on Earth. Anyway, Sabine, this is a long-winded question, but do you believe that the lack of evidence of life from Earth on another body in our solar system can provide some Bayesian prior on the existence or the ability for panspermia to take place? In other words, for life to get spread throughout the cosmos as soon as it gets created?
Well, of course, in principle, yes. But we don't have a terrible lot of evidence about, microbial life on other planets. Like, we've just about made it to Mars and maybe to the Moon. but what do we know about the other planets? And then there's this whole issue about the habitable zone, right? If you're only looking at planets in the habitable zone, then this planet is it, right? So I'm not sure how useful this evidence is. It's certainly evidence, and you should include it into your priors. But it's totally outside my research area.
Yeah. Okay. Well, that never stops me from just wild speculation. Something that is in your research area is, of course, cosmology, quantum cosmology. Gravity, early universe, because in fact, that's how we met. 13 years ago, my wife was pregnant, and I think you were pregnant at the same time. We met in Sweden. You organized this wonderful conference on quantum gravity and observational evidence for quantum gravity. Often I hear in my field, cosmic microwave background experiments, polarization experiments, like the Simons Observatory. There's a beach ball behind me. You're watching on my YouTube channel, Dr. Brian Keating, or Sabine's YouTube channel, which is Science Without the Gobbledygook. We often talk about the dispositive evidence that detection of B-mode polarization, if truly primordial and not from dust, that would be provative that inflation took place. So I want to ask you, first of all, a question that you are such an expert on, which is quantum gravity. If I say, Sabine, I detected a radio wave today, and that's proof of there being photons, quanta of electromagnetism, isn't that the same as me saying I detected a gravitational wave at the surface of last scattering, and therefore there must have been quantum gravity from these primordial polarization perturbations? Aren't we kind of putting too much evidence on, as I hope that we will discover something, but isn't it too much to say that would be evidence for quantum gravity to detect classical sized perturbations at the surface of last scattering?
Yes, I think that would be too much to say, but I don't think that's what people are saying, right? As you correctly said, they are claiming it's evidence for inflation. And of course, in inflation, the idea is that you get those waves as a relic from the quantum fluctuations and so forth. But from the B modes themselves, you can't actually infer that this had to be the case. And as you certainly know, that there are particular types of inflation where you wouldn't be able to detect them. And then there are other theories which are not inflation, which actually make the same prediction. So you get this whole what's called the inverse problem. If you make the observation, can you actually figure out what the correct theory was? But having said that, there are other signatures that you can look for in the CMB, at least theoretically, that would actually allow you to pin down that the original fluctuations must have been quantum in nature and can't have been classical stochastic fluctuations. And the people have written papers about this like 10 years ago or something, around the time maybe that the workshop was, stuff like this. And it turns out that it's just really, really hard to measure. So the current measurement precision just isn't there, and it's probably not going to be there within my lifetime.
So I just turned on my computer light system now. That's great. So Sabine, another theory that stands in contrast to inflation are so-called bouncing models, or cyclical models. And I want to turn to that. That's part of a wonderful chapter in the book. And I never like to give away the book. I don't want to give away too much, except to say that you have to buy it. You have to buy it in as many formats as I have it, which is hard copy, digital ebook, and audio copy. So please, Sabine's twins need to go to expensive school in America. Anyway, Sabine, you talk about these alternatives, and you say, I quote, the bouncing model and the cyclic models are, quote, worse than inflation. So first of all, I want to ask you, can you define what these bouncing models are? You talked to one of the foremost proponents of them, Sir Roger Penrose, Nobel laureate in this book, who you presuppose, actually, this is amazing, Sabine. In the book written in 2019, 2020, you say, I can't believe he hasn't won a Nobel Prize. And then he wins a Nobel Prize in 2021 when the book is finished. Anyway. He has
I didn't just write this
most popular
for
models called the conformal.
Sorry, I didn't mean to interrupt you. I didn't just write this for the book.
Say again?
I actually wrote this on my blog before he won the Nobel Prize. So you don't have to take it on my word.
Well, Sabine, can you tell me what the Powerball lottery numbers are going to be next week? I'd really like to know to support the Into the Impossible.
I can't.
So he has this conformal cyclic model. He has these Hawking points. I want to talk about this, and also past guest Anna Aegis, who has been on the show recently talking about cyclic models. Why do you say it's worse than inflation? Is it like what Winston Churchill said about democracy, the worst form of government, except for all the others? Is it true that bouncing models are really worse than inflation? If so, how?
Well, I'm not sure I said that it's worse than inflation, but it's worse than lambda CDM, like what you could call the standard Big Bang model, basically. And I would say that inflation is already tacked onto this model, right? And so the reason why I say it's worse is that you're inventing a more complicated story that comes before the beginning, basically. So you're tacking on this whole story about an earlier universe which collapsed, and then if you're with Penrose, and you talk to him on your channel, then he gives you this story about supermassive black holes that radiate and that leave some kind of imprint in the cosmic microwave background in our universe. And the obvious question that you should ask, why don't you just start with an initial state that had this imprint? Wouldn't this be much simpler than inventing this complicated story for how they came about? And so I think that all those models are running into this problem at some point, that if you go back in time, the initial state becomes simpler and simpler and simpler. And if you want to attach a more complicated story that happened earlier, there's no scientific justification to do this.
Okay, so on the bouncing model, the criticism that you actually say is that the problem with these ideas is that they have no explanatory power. They do not simplify the calculation of any observations. So I don't know, if you followed closely the battle between, people like Will Kinney's and the Paul Steinhardts and the Anna Aegises, but they do claim that they can make all predictions with actually simpler observation. They don't actually need the inflaton. They don't actually need to instantiate a singularity, and their bounce is purely classical. So yes, they need a pre-existing universe, but they don't need, or they need some space-time at least, but they don't need a singularity where there is perhaps no hope of computing anything that is built on such a shaky foundation. So what do you say to those new instantiations of that model, which suggests that you don't need a Big Bang at all? You just need this slow collapse from a previous universe. It doesn't have to be that violent even.
So first of all, you just reappeared. I can now see you again. So I would like to correct what you said there. You said that I'm claiming those models don't have any explanatory power. That's not what I'm claiming. I'm saying they don't improve the explanatory power of lambda CDM. So they just add unnecessary clutter to it.
I was just quoting from the book. The problem with these ideas... Yeah, I was just quoting. The book actually says that they have no explanatory power, but I understand you're not making that strong a claim right now.
Yeah, right. So if you add them, so this is what I explain in the book, right? So you can always add an earlier story, and it's this earlier story that has no explanatory power. You could as well just take lambda CDM and be done with it, and that's in practice, what cosmologists do if they run their simulations. You don't have to start with a complicated story about this earlier universe. It doesn't actually aid any of your predictions. And of course, those people would disagree. They would say, well, in some sense, this is actually simpler than inflation. And I don't know, maybe it is. But as I said earlier, it's not that I'm a fan of inflation, right? To me, it's just replacing one evil with another evil. We don't need either.
So in terms of the competing alternatives between the conformal cyclic cosmology, the bouncing, the ekpyrotic model, There are some alternatives from Neil Turok, who's an upcoming guest on the Into the Impossible podcast, or actually by this time it'll be a past guest because that's coming out soon. So yeah, I guess the comment that I would have is, how do I, as an experimentalist, what do I do? I mean, what's nice about inflation is that it's making predictions. Some would claim it does, and that one of the most robust predictions, in fact, the only one that is, intrinsically robust, it seems, agreed upon by everybody, including Roger and including Paul and Anna, is that there'd be these primordial gravitational waves. But as you said, the amplitude of these waves is incredibly sensitive to the actual fourth power of the energy scale of inflation. Therefore, inflation could have happened at a very, very slightly lower energy scale, raised to the fourth power. Anything gets very small, and therefore we wouldn't see it. So it might be true, but unfalsifiable or unprovable, rather. So of the alternatives, what's nice about them is that you could rule them out, right? Because you could observe gravitational waves, which would, in some sense, or error bonds or whatever Roger talks about, right? So is there any... at what point does the virtue of being falsifiable enter into your calculations as a theoretical physicist? Is that a virtue at all of these alternatives to inflation, that they can be disproven?
Well, in principle, yes, but in practice, I don't think it's going to happen. But because, I mean, you know how theorists are. If you come with your observation and say, well, I've disproved it, they're going to twiddle something about their model, and then they can make it work. Right? This is what theorists do. So I'm not buying it. There's too much freedom in those models.
Mm-hmm. So pivoting to the unobservable multiverse, now to the collapse of the wave function, my final question before we get to audience questions, and that is, we talk a lot about what is knowable in this book, and actually the conversation with Roger Penrose is not about his conformal cosmology, it's about the measurement problem, the orchestrated collapse, he calls OR. So I'm going to have him and Stuart Hammeroff, his collaborator, on the podcast coming soon, so stay tuned for that. And you quote from this passage by Bertrand Russell that the chicken is fed reliably every morning at 9 a.m. until one day the farmer chops off its head. More refined views as to the uniformity of nature would have been useful to the chicken. I want to ask you, I was dreaming about, what would I ask Sabine that she's never been asked before? In this book, you talk about your favorite part of physics that does what we call outreach, and that's the minimized action principle, which I agree is pretty cool. But I want to ask you, I think the weirdest thing about physics, in my opinion, quantum physics, now we're talking about collapse of the wave function, the chicken's head getting cut off, I think what's most fascinates me is that in classical physics, we can form commutation relations between position and momentum, and those can be used to construct the action, which can then be minimized in your favorite theory. But my favorite thing is by adding just one number, an imaginary number, the square root of -1, we get in quantum mechanics that P and Q do not commute, right? Isn't that really weird, Sabine? How is it that, and that's sort of the most quantum of all quantum things, is that you can't, measurements don't commute. What is this telling us? Is this significant that in classical mechanics the commutation relation vanishes, and in quantum physics it doesn't vanish, and in fact it involves the square root of -1? Where the heck does that come in? This has always really troubled me, and I'm curious, what do you make of this strange behavior of a mathematical object? Am I just lost in math, Sabine?
No, I'm with you. I mean, but I'm afraid I can't answer the question. So I've always, though maybe I look at it from exactly the opposite direction. As I've said a few times, I originally studied mathematics, not physics, and I've always found complex numbers to make much more sense than real numbers, which I dare to say probably a lot of mathematicians would have the same attitude. Well, because in the real numbers, you can't solve certain equations, right? It's not complete. So in the complex numbers, you have all this stuff with the holomorphic functions, and I dare to say it's beautiful, blah, blah, blah. So to me, the question is more like, why do the observables only take on real numbers, like the values? Why are they real numbers? What happened with the with the complex numbers, or to put it differently, why are all the measurement operators Hermitian? I have no idea. I think it's an interesting question. Like, where do all the I's go? So it's basically the opposite to your question.
Right.
But I don't know. Yeah, very good question.
And then I guess I would ask, well, wouldn't you be more in love with the quaternions and the Clifford algebras? And I mean, at what level does it stop? That it stops being beautiful or interesting. Okay, well, we've reached the end of. I only have one more question, and that's not a very personal question, but I want to ask. Your YouTube channel is seen by 500,000 people on average on video channels, and I know you do make a nice income from it, and that's wonderful. But what is being on YouTube? What does it give you besides income or fame or attention? What does it fulfill for you? Why do you do it? Besides the money, as I said, I mean that is important.
Well, I love science, and I want to share it with other people. It's really pretty simple. It also gives me an excuse to learn a lot of new things. I mean, as you've probably noticed, it's like half of the time I talk about physics that I'm really familiar with, like the principle of least action. I recently made a video about this. I have one coming up on the multiverse. I just talked about the block universe. So this is the kind of stuff that I know, where I'm like, okay, I know it. Other people are interested in it. So I just share it with them. But I also talk about stuff like nuclear power, like how green is it? How much do we have to worry about air pollution? And I have one coming up on energy storage, like how does it change the carbon footprint? What do we do if the sun doesn't shine and the wind doesn't blow? That kind of question. And I just learn a lot from it. And then it makes sense, right? So once I've put in the effort, I share it with other people, so they get something out of the work that I do.
Yeah, it is really delightful. It's one of the few that I have a notification bell set for besides this channel. So you should all subscribe. I'll have a link to her channel down there, or maybe up here. And it's called Science Without the Gobbledygook, and it is delightful. I mean, you literally talk about everything. I mean, places that I would never fear to tread. You talk about transgender athletes, which is a favorite video that I was. I can't say I was surprised that you made it, but I was glad that you made it. It's very interesting and provocative. You did one. Does 2 + 2 = 5? Question mark. So you're not afraid to tread into very interesting waters. And before we had started this conversation on recording it, you mentioned that, sometimes you get people that unsubscribe or that send you, email, oh, you should do this or that. How do you react, as someone who's, aspiring to grow an audience the way that you have? How do you handle the naysayers, the haters, the trolls and stuff? How do you do that and maintain? I mean, you are known as a curmudgeon in some ways, or a contrarian, but you're actually very cheerful, and I love that about you. But how do you handle the naysayers? And does it get it and hurt you in your heart at all?
Well, you know what they say: haters gonna hate. I think if you reach a certain level of popularity, you have to expect that kind of thing. There'll always be people who will try to put you down one way or the other. And I think I've just been doing this for too long to really be bothered by it. Sometimes I do get things wrong, but I think I'm genuinely, honestly trying to get it right. So, for example, the thing where I talk about trans athletes, it was just something that I was wondering about. Like, I was like, what are people talking about? Why is it so controversial? What does the one side say? What does the other side say? And then, as I just said, I thought, well, now I've made the effort, and I think I roughly understand what they're talking about, and those are the key points. Let's make a video about it, because maybe other people find it useful. And I think what you see from the amount of people who watch the videos is that, yes, there are a lot of other people who find it useful. So that's how I think about it. I think I'm being useful. That's the bottom line. Okay, so now I'd like to ask you some audience questions, and then I have my patented
questions that I call the quintessential quattro, the Fantastic Four, which have been updated since the first time you were on the show 2 or 3 years ago. Okay, first question comes from audience member who has a lovely name, which I would have reconsidered for one of my kids, and his name is Zero Skull. And he says, first of all, remember, it's Sabina, not Sabina. Okay, fine. Thank you, Zero Skull. But he says, he wants to ask you, Sabina, what misconception about science do you see most often from your audience?
Misconceptions about science or scientists?
Either. He's asking about science, but I'm interested in either answer.
I think in the denialist camp, you get a lot of people who are like, they're just in for it for the money, which I think is just ridiculous. Like, if you know any scientists, right, in academia, money isn't the reason they're there.
Right, exactly. He also asked about, do you read any science fiction?
Not recently. I on occasion read some kind of short story, but recently I've been more into fantasy. I've discovered there's a genre called urban fantasy, which I think is pretty cool. So, you know, they're werewolves in London and that kind of stuff, and I think it's awesome.
Okay. Oh, great. So a few more questions from my YouTube audience, and then we got some on Twitter. So reminder, you can subscribe to Sabina's channel, and then I always take audience questions. So I've got an interview with Roger Penrose coming up. So leave your questions on my channel. For those folks, I have an interview with Matti Milgram coming up, Sabina, which you'll be interested in. We talk about some of your ideas in phase transitions and condensed matter, dark matter ideas, superfluids. So there's another question that's coming from someone named Scarlace. And Scarlace, he or she says, I love her videos. I have a question for her. She has repeatedly bashed theories like string theory for being scientifically lacking in their predictive power or provability, yet she believes in superdeterminism. How does she rationalize this position?
Well, because superdeterminism does make predictions. I mean, like, I've given talks about this, I've written papers about it. The problem is that the experiments are not being done. So I'm trying to get people to actually do these experiments. I'm always surprised that people think I'm bashing string theory or that I'm highly skeptic of it or something. I actually think that string theory does have quite some merit. You know, it's based on a good idea, and it was trying to solve an actual problem, which is the missing quantization of gravity. I think it kind of went into the wrong direction when they were trying hard to make things work out and so on and so forth. So maybe if they had been a little more intellectually honest early on, then it wouldn't have gone downhill quite as far. But I mean, there's some interesting things that have come out of it. And the ADS-CFT stuff is certainly worthwhile. So that's all fine with me.
Mm-hmm. So Cisnad Citos asked, what do you think about the free will theorem? And have you seen John Conway's lectures on it, his philosophical arguments? I think if you look at it the right way, free will theorem and superdeterminism will turn out to be equivalent. Now, I always say, Sabina, I believe in free will because I have no other choice. But what do you make about this? Free will, obviously, it plays and I think the main answer is buy the book, because she covers that in great detail, and she has some videos on it. Buy it. Listen to it in all three formats. So maybe we'll move on to other questions. Here's a question. The Nothing Channel. Sabina is critical of the particle physics field, but is also against building larger colliders. I understand her points, but then how does she think we go forward? Should we just give up on particle physics until we get more clues to guide us? And how will we get those clues? Thank you, Nothing Channel. So how can you be against future particle accelerator and
it's not that I'm against particle physics or something like this. I've been very specifically against building this super expensive future circular collider, because I just think it's too much money for too little benefit. Now, there are certainly interesting things that you can still do in particle physics. It's not that I'm saying let's throw out all particle physicists. I'm not quite that bad. But also, I mean, I've extensively talked about what we should do instead, right? I've literally written a whole book about it. I'm saying we should focus on trying to resolve actual inconsistencies. For example, the missing quantization of gravity is one of them, and there's the measurement problem. There's also dark matter, which you just said you'll be talking about with someone in your channel in the near future. So, which of course we're already doing experiments about, like for example the Webb telescope, right, is giving us better data as we speak, and there's certainly something that we will learn from it about dark matter. So it's not like we're completely stuck without building this huge collider.
Mm-hmm. Someone with a name I shouldn't pronounce says, will you ever have another discussion or debate with Bernardo Kastrup, who's an upcoming guest on my podcast? See, I should reference that you debate on Kurt Jaimungal, my friend Kurt Jaimungal's Theory of Everything channel with Bernardo. Bernardo's coming up next week, so on my channel. Do you have any advice for me, or should I cancel the interview?
Well, you know, I like to think of myself as a fairly open-minded person, so I wouldn't entirely rule it out. But I do feel like it was a mistake, because I was expecting a scientific conversation, and it wasn't one. I had the impression he didn't really know what I was talking about to begin with, and it wasn't fruitful. So I thought it was pretty much a waste of time.
Do you have any questions that you'd like me to ask him as a listener to my conversation with him?
No, honestly, not.
Okay. Good. Okay, so now we're going to go to Twitter, where Sabine is prolific and monumental in her questions and answers and hot takes on all topics. So her Twitter handle is SKDH. Ask her, Paul Simeon is asking, ask her to explain why statistical independence in the Bell inequality test is a stand-in for the desire of some physicists to have libertarian free will. Now, again, this is a major topic of the book, but I would just say, could you summarize that do these tests, the Zeilinger test, the other thing, do they have any, have they influenced you in any way, or do you think that there'd be, basically no point in really revisiting them? What's your take on these Bell inequality tests, the Zeilinger test, and et cetera?
So I have no idea why statistical independence was connected with free will. I don't know if you saw that Matt, whatever his last name, from PBS Spacetime, made a video about superdeterminism a week ago or something. And he made this pretty clear, and I think it's entirely correct. It has nothing to do with free will. I think the way that he put it, which I thought was pretty funny, if philosophers have decided exactly what they mean by free will, we can talk about it again. And it's not going to happen, right? So I'm afraid it's one of those cases where physicists attached a certain label to a mathematical assumption, and people just took it to mean too much. So I think we'd all be better off if we wouldn't refer to statistical independence as the free will assumption or the free choice assumption.
Great. Okay. Last question from the audience on my Twitter channel. I mean, we have many, many more, 150 questions across all my platforms. People, we could go all day. I think the last one I'll ask is related to something that past guest Don Hoffman said on my channel, and upcoming guest, Dr. Nima Arkani Hamed, who's promised repeatedly to come on, so hopefully he'll make good on that. I'm going to see him next year in the UK, so I'm going to bring my trusty recorder with me and act like Sabine on a journey to understand these heroes. But anyway, Nima says that space-time is doomed. What do you think of him? Actually, let me ask you a first question, Sabine. I've never understood this quote by your countryman, Albert Einstein, who said that hereafter space-time is doomed to never, to the dustbin of history or something. I don't know. He said something about that. He was wrong, almost as many times as he was right. And it's too bad because he could have had a good career, as I always say. But anyway, what did he mean by time is doomed and space is doomed and only a union of the two will survive? What does that mean? Is that just hyperbole? And then what are your thoughts on Nima's kind of echoing of the great of the great Einstein?
Okay, so my history might fail me, but I think it wasn't Einstein, it was Minkowski, because he introduced Minkowski, space-time, and he made this statement about how space and time on their own are doomed to fade into whatever. I can't actually quote it. But of course, it was Einstein who actually figured out what to do with it, right? So this is where Einstein comes in now. What string theorists or what Nima mean with this today, I believe they mean that space-time is emergent in some sense. It comes about from something else. It's like an approximate description, and there's some underlying reality. And that may be. I'm quite sympathetic to this idea, but I also don't think that it necessarily has to be the case. It might just be that space-time ultimately is the fundamental thing.
Mm-hmm. Yes. So you're right. Minkowski said that space and time itself are doomed to fade into mere shadows. But Einstein had some questions. He said, time, in other words, is an illusion. People, the past and the future of time, Anyway, Einstein said so many things. He's like what Roger Penrose says about Stephen Hawking is that you should always have made a bet with him because he was either wrong or eventually he'd flip his perspective and you'd win the bet no matter what. And we didn't get into black holes and information. I'm sorry. We'll save that for part 5. So Sabine, we are now going to go into the impossible with the patented Fantastic Four or quintessential quattro existential questions with Sabine. But to get access to those existential questions, you'll need to subscribe to my newsletter, which is briankeating.com/list, and also subscribe to Sabine's newsletter as well. I'll have links to those in the show notes below. And Sabine, I want to thank you for everything you do around the world, inspiring literally millions of people through your videos, your books, your blog, your newsletter, all of which I subscribe to. And you should too, and get this wonderful new book and her first book, Lost in Math. It's a beautiful companion to these two. Anything else you'd like to mention, Sabine, that you're like my viewers and listeners to know about?
No, I mean, this is just wonderful love talking to you. I think you have a great channel with a lot of super interesting interviews. Thank you,
Sabine. That means the multiverse to me. All right, I'll let you get on. Good Nacht, Danke Shane, and I'll see you again soon, I hope.
Any sufficiently advanced technology is indistinguishable from magic.